Good morning. Today I am going to explain about the capacity of the parallel plate capacitor with dielectric slab. This is one of the important topic in capacitance and capacitor. Here we have to consider, let us consider there are two parallel plates are there and those two plates are separated by some distance d, and in between a dielectric slab is placed whose thickness is T. So those points I wrote, that is, let us consider a parallel plate capacitor of plate A and B, and those two are separated by some distance d, and let a dielectric slab of thickness T is placed or inserted between the two metal plates. Now we know that the intensity of the electric field in air can be written as E air is equal to rho by epsilon naught. So I have given a note how we got this equation. So we know that according to the Gauss law in electrostatic, that is E dot ds is equal to q by epsilon naught. So this can be written as E out 1 dot ds is equal to q by epsilon naught. We know that 1 dot ds is nothing but it's a integration of surface is equal to the area. So is equal to the q by epsilon naught, and E is equal to q by epsilon naught a. So q by a is nothing but a charge density rho. So I can write in terms of rho by epsilon naught. Epsilon naught is nothing but it's a permittivity constant. Now here this is the intensity of the electric field when only air is there in between, there is no medium or there is no dielectric constant. Now suppose intensity of the electric field in medium or with the dielectric constant is can be written as Em is equal to, M is for the medium, rho by epsilon. So here we know that K epsilon naught is epsilon. So K is equal to dielectric constant. Here the potential difference, now we have to calculate the potential difference. So potential difference between the two metal plates in air is can be given as potential difference. By the definition of potential difference, I can write intensity of the electric field and the distance. So here intensity of the electric field we got, that is E is equal, E air is rho by epsilon naught, and D value is, we have to consider the situation in air means capital letter D minus small letter t. Okay, so D minus T. Now potential difference between the two plates when the dielectric is introduced between the two plates. So when the completely dielectric is introduced between the two plates, so that time T is equal to the D. So I can write D is equal to the T. So rho by Em is already we got, that is value of intensity of the electric field in medium, rho by epsilon into dt. So now the total potential is nothing but a potential due to the when there is no medium, and the potential when some medium is there. So here V is equal to V air plus Vm. Now so we substitute the value of V air and Vm, then we got the equation V is equal to rho taken out, then T minus T by epsilon naught plus T by epsilon. Let us take that is equation number 1. Now capacity of the parallel plate, we know that by the definition of the capacitance, C is equal to Q by V. It's a ratio between the charge and potential. So here we know that Q is nothing but a density into area. So here Q is replaced by Q rho into area. A is the area of the plates. Now here C is in this equation we are substituting the value of C is equal to Q by V. So V value is equation number 1. So equation 1 is substituting, and Q value is rho into A. Okay, now C is rho get cancelled. C is equal to A by D minus T by epsilon naught plus T by epsilon. Next here C is equal to, so if you take the LCM, then it becomes C is equal to epsilon naught epsilon A by D minus T epsilon plus T epsilon naught. So we can write this equation D minus T, if you take to this side, then it becomes epsilon naught by epsilon into T. So we know that K epsilon naught is equal to epsilon. So K is equal to epsilon by epsilon naught, and 1 by K is equal to epsilon naught by epsilon. So epsilon naught by epsilon is can be written as 1 by K. Okay, now C is equal to K. So if this goes up, then it becomes K epsilon naught A D minus T K, if you take the LCM also, plus T. Then C is equal to K epsilon naught A by, so just multiplication of these two, dk minus dtk plus T. Then C is equal to K epsilon naught A by dk. If you take the T is outside, then 1 minus K. So this is equation number 2. Now let us suppose if the medium is completely filled with the dielectric constant, so that time D is equal to the T. So I can write this equation number this term. So T value is D. So dk minus dk we got. So dk minus dk plus D. Okay. So dk get cancelled. Then C is equal to K epsilon naught A by D. Thank you. For more videos, subscribe my channel Physics.